Today we're going to continue our lovely journey of graphing quadratic functions. We're going to show you some applications of it, but we also want to be able to go from our best friend standard form to our best friend vertex form. So before we even attack it, let's recall what standard form and vertex form are. So there's your standard form, and our goal in this part is we want to convert this to vertex form, and let's recall what vertex form is. It's y equals a, this time we have parentheses, x minus your h squared plus k. Now remember that your h and k, that gives you the vertex. Notice that this a, the leading coefficient, is the exact same as this a, leading coefficient over there. So what are our steps? Number one, we're going to identify a, b, and c, or it's just a, b, so that we can find the vertex. The vertex is two-part. We have to find the h and the k. Then all we do is substitute the a, the h, and the k into vertex form. And that is the extent of what we're working on here. So first off, what's my a value here? My a value is in front of the square term. So my a is -2. And my b value is -4. Remember that your b's and c's can be 0, but your a cannot, otherwise it becomes linear. Now, what we're going to do is find the vertex by first finding the x value of the vertex. Now remember, it's also called h, so I'm going to say x equals h in this case. And I'm going to use the -b over 2a All right, so let me substitute in. My b is -4, and my a is -2. And what does this simplify to? The double negative is positive, but I still have another negative down in the denominator. So I end up with -1. Now what do? I take that, and I'm going to substitute into the function in order to find k. So in this case, I'm actually finding k now. So again, feel free to call it k or just call it y, whatever cranks your tractor, whatever floats your boat, whatever waxes your lip. So -2 times -1, and we have to square that, minus 4 times -1, because I'm substituting it in, and mas 6. For your polyglots, that's +6. All right, now we simplifico here to get -2 times 1, because the double negative is positive there, -1 squared. -4 times -1 is +4. Bring down the +6. And my final value here for k is going to be chito loquito. So what's my vertex? -1, -8. All right, good. Thanks for checking me. That's positive there and a positive there. And now the easy part. All we're doing, substituting in. Remember what vertex form is. Remember, the more you write it down, the more it's in your head. So since we're using it, let's write it down. All we have to do is substitute in our a, which is -2. We're going to put it right there. Our h, which is -1, I'm going to place it here. And k, which is chito loquito, right there. So my final result is this, -2 times x plus 1. I have to take the opposite there, quantity squared, plus 8. So I'm claiming this is my answer. So how do I know this is my answer? We're going to check with tech. So I'm going to go over to Desmos to do that. Please pull out. All right, and so we see here that our h is going to be +1, our k is -7, and when we substitute in, we get this. And of course, when you double check with your tech, you can see that you are correct. All right, we're going to take a gander at one application, or actually two types. One is going to be monetary application, and the other one is going to be an object being tossed, being thrown. So I'll read through with this, follow along. You and a friend are hiking in the mountains and you want to climb to a ledge that is 20 feet above you. The height of the grappling hook you throw is given by the function here. Because of course in the woods, you know that and you figure it out, I'm sure. So what is the maximum height of the grappling hook? So just to set the stage, here's a little ledge cliff thing, and here's little old me standing there, and I need to toss this thing, and hopefully it gets to there, right? Hopefully it gets to there. Now, by the way, let's just describe what things mean. H is height, and T means time. And usually it's in seconds. So after half a second, how high is the grappling hook? After 2 seconds, where's the grappling hook? So that's what we're going to try to figure out here. When we toss the thing, will it reach? So ultimately, what do we have to find? What piece of the parabola is the most important? We need to find the vertex. Because the vertex here tells me that it is a maximum. So I need to know if the maximum is going to be 20 feet or more. Okay, now of course, you could simply just plug this whole thing into a graph. If you plug this into a graph, just into your calculator, and then trace over to find out where that vertex is, that'll actually tell you the answer. So we'll look at that momentarily, but right now let's actually spend some time just calculating. Since I need to find the vertex, I'm going to start off using x equals negative b over 2a. And let me actually change that from an x to a t. Why? What we're finding is the time it takes for the grappling hook to reach the highest possible point. Well, my b is 32, so I plug that in. My a is negative 16. Double negative here is positive. And what did I just get? Please discuss. So we see here that this makes sense. So far, at 1 second, this is the highest it gets to, the grappling hook. We also know it can't be negative because I'm not going backward in time. So now I take the 1 second and substitute in to my original function. We'll explain momentarily where these numbers come from, and I won't spend too much time, but just to explain briefly where stuff comes from. In physics, there are functions to figure out how to find out these values, but generally this is what this means. This one right here is pretty much the constant that comes from gravity. Gravity is pulling down at a certain rate. And that's what this is, pulling down at a certain rate. Acceleration, actually. Force. This one right here tells me the initial amount of force. Because once I throw the grappling hook, I let go of it. I don't keep applying force to it. I just once throw it. And this has to do with the force, in other words, like how much, what's its initial speed when I let go. That's kind of what this is about. And this is somewhat related to the height of the object when it starts off. That's somewhat related. Not perfectly, but close to it. All right. Now when we substitute here and simplify, I get negative 16 plus 32 plus 5, and my final result is 21. And more specifically, 21 feet. And what does that mean? Can you throw it high enough to reach the ledge? This is a yes or no question. What's the answer? Yes. Yeah. The answer is yes. And if asked why, the reason is because after 1 second, this puppy reaches 21 feet. Please don't throw puppies.